In this video, we're going to talk about the geometric transformation called a reflection. Now, a reflection is just flipping an object over a line, or sometimes we say flipping an object through a line. And the first reflection we're going to do is we're going to reflect this triangle over the x-axis. So let's take a look at this. Example number 1 says, reflect triangle ABC through the x-axis, or over the x-axis. So if you can kind of imagine the x-axis, that's the line we're going to flip our triangle over. Imagine there's a mirror on that line, and everything that's up here is going to be reflected through this mirror that's sitting on the x-axis. So essentially we're going to take this image that's right here, we're going to flip it over the x-axis. So first we want to start with our 3 coordinates, coordinate A, B, and C, which are labeled here on the triangle. We're going to flip each one of those 3 coordinates over the x-axis. So let's see where those would be after we flip them. Let's see, if I start with coordinate A, that's this point right here, and if I flip it over the x-axis, reflect it over the x-axis, that's going to put that point right there. So that'll be point A prime. Let's see, and that'll be point, coordinates of that point will be -1, -1. If I take point B and I reflect it over the x-axis, let's see, that's going to put it right here. So that's going to give it coordinates 2, -4. I'm going to call that B prime. B prime is just the reflection of point B. And then C, we're going to reflect that over the x-axis, and that's going to put our point C prime right here at point 4, -1. All right, so we've just reflected each one of those 3 points. I connect them all up. And now I have an image, a reflected image. I started with this green triangle here, ABC, reflected it over the x-axis. Now I've got a reflected image, triangle A prime, B prime, C prime. Now, let's look at what the vertex matrices are going to be for these 2 triangles. Now, if you remember, when we're writing our vertex matrices, we always put the x's on top and the y's on the bottom. And then we have the coordinates for A, B, and C in our columns here. So the coordinates for point A, x coordinate is -1, y is 1. Coordinates for B, x coordinate is 2, y coordinate is 4. And the coordinates for C, the x coordinate is 4, and the y coordinate is 1. So that's my vertex matrix for my given image. And my vertex matrix now for my transformed image, my reflected image, is, let's see, A prime is -1, -1. Those are my coordinates. B prime is 2, -4. And C prime is 4, -1. So now I've written the vertex matrices for these 2 images, just the coordinates of the vertex points for each one of these 2 images. Now I would like to write the algebraic rule that expresses what exactly we do to each of our coordinates in order to perform this reflection over the x-axis. And so to come up with this rule, I just want to look at what exactly I did to each one of my points and see if I can figure out what's the pattern here. What did I do to each one of my coordinates in order to transform the given coordinate into its transformed coordinate? So let's see. A started out as -1, 1, and it became -1, -1. B, I went from 2, 4 to 2, -4. And here I went from 4, 1 to 4, -1. So it looks like all of my x coordinates are staying the same, and all of my y coordinates I'm making negative. So my algebraic rule then is going to be x stays the same, my x coordinate stays the same, and my y coordinate, it becomes the negative of whatever my initial y coordinate was. So now I know what the algebraic rule is for this particular reflection, a reflection through the x-axis. Let's take a look at a reflection through the y-axis. I'm going to start with my same triangle that I had before. Triangle ABC has the same coordinates. Only this time I want to reflect it through the y-axis, which means my mirror is going to be along the y-axis, and I'm going to reflect this image across the y-axis. So let's see what that new image is going to look like. I'm going to take each one of my given vertices, and I'm going to reflect them across the y-axis. And I'm going to save my A vertex for last. So let's do B first. Let's see, B is at 2, 4, and I want to reflect that across my y-axis. This is my y-axis. This is my x-axis. Get my red pen. So I want to reflect this across the y-axis, which means that's going to come over to this point right here, which is going to be, let's see, that's B prime is going to be -2, 4. C, if I reflect it across the y-axis, that's going to be over here. 4 that way, it's going to be 4 this way. So let's see, C prime is going to be -4, 1. Now, my A coordinate, I'm going to also reflect it across the y-axis. Notice, though, that my mirror is right here on the y-axis. Since point A is already on this side of the y-axis, when I reflect it across the y-axis, it's going to reflect over to this side. So A, my point A is going to go from here over to here, and A prime is going to become coordinates 1, 1. So now I've reflected each one of my vertices. Now I just have to connect them up and draw my triangle. So let's see. And now I have triangle A prime, B prime, C prime, which is a reflection of triangle ABC. Now that I have my graph, I've graphed my image of my reflected triangle. Now I want to write my vertex matrices for this new triangle, for my given triangle and for my new triangle, just like I did before. So let's see. My vertex matrix for my given image is going to be just the same as it was before. I'm starting with the same triangle. My x's go on top, my y's go on the bottom. A is -1, 1. B is 2, 4. C is 4, 1. And my transformed image, A prime, B prime, C prime, let's see, A prime is right here. That's the coordinates 1, 1. B prime is -2, 4. And C prime is -4, 1. So now I've expressed my given image and my transformed image in terms of matrices. Now I just need to write down what my algebraic rule is. What's the general rule for what I have to do to any given point if I want to reflect it through the y-axis? Well, let's take a look at what we had to do with each one of our points and see what pattern we come up with. For this point here, point B, started out as 2, 4, and it became -2, 4. This point started out as 4, 1, and it became -4, 1. I think I'm starting to see a pattern. Point A started out as -1, 1, and it became +1, 1. So it looks like my y coordinates are all staying the same. 4 stays 4, 1 stays 1, and 1 stays 1. But all my x coordinates are becoming negative. So when I reflect across the y-axis, my x coordinate stays the same, and my, oops, I messed that up. It's my y coordinate that stays the same. 4 stays 4, and it's my x coordinate that becomes negative. So my algebraic rule I would express like this. X comma y goes into -x, y. Now we're going to do a reflection through the line y equals x. Now, in order to do the reflection through the line y equals x, I want to first sketch this line y equals x on my set of xy axes here. So here's my x-axis, here's my y-axis. And the line y equals x, well, that's just the line that has all of the x coordinates equal to all of the y coordinates. So let's see, if these are coordinates 1, 2, 3, 4, these are 1, 2, 3, 4, well, 1 is equal to 1. Here's the coordinate where x is equal to 1 and y is equal to 1. And here's where x is 2 and y is 2. And let's see, x is 3 and y is 3. So I'm going to have a diagonal line that goes, in this case, it goes right through where my triangle is. And I want to reflect this triangle across this line. So let's see what that's going to look like. So let's see, let's start with point A here. If I want to reflect point A across this line, in other words, I want to imagine a mirror on this diagonal line here, and I want to reflect point A across that mirror, point A is going to go to this point here. Reflect that across the mirror. So that looks like the point 1, negative 1. So let's see, that's going to be A prime, 1, negative 1. And let's see, point B, I want to reflect that across this line here. Point B is going to become point, let's see, 4 and 2. It's going to go to this point right here. So this will be B prime, which has coordinates 4, 2. And now C starts at this point. I want to reflect that across my y-axis, and this is going to go to the point 1, 4. So C prime is going to become 1, 4. Now I just need to connect up A prime, B prime, and C prime. A prime, B prime, and C prime. And now I have an image of triangle ABC reflected across the line y equals x. So now let's see what our vertex matrices are going to be for our given image and our transformed image. Our given image, same one we've been working with, triangle ABC. X is on top, y is on the bottom, so point A, negative 1, 1, B is 2, 4, and C is 4, 1. And A prime, B prime, C prime, let's see, A prime is 1, negative 1, B prime is 4, 2, and C prime is 1, 4. So now I have my vertex matrices for my given image and my reflected image. Now I just need to come up with the algebraic rule that describes what I need to do to my points in order to reflect them across the line y equals x. So if I look for the pattern in this case, it may be easier to look at just the vertex matrices. If this is the vertex matrix I start with, and this is the vertex matrix that I end with, you can see that all of my x values, they start here on the top, and they get moved down here. All my y values get moved up here. I'm essentially just swapping my x values and my y values. So my algebraic rule then I can express as, if I start out with the coordinates of a point x, y, those are just going to swap. And x will become y, and y will become x. So there's my algebraic rule for reflecting an image across the line y equals x. Now, in your notes, you have a couple more examples where I ask you to take a given image and transform it. And so I want you to do that using just the matrices. Notice I didn't ask you to graph it. We're going to take a look at that tomorrow after we look at this. So just graph it using your algebraic rule and write the vertex matrices for the given image and for the transformed image.